Hello guys, and welcome back to Retron channel on YouTube. So in the last video, in the previous video of Altium Designer that made by our YouTube channel was focused on how to create your own integrated library, which means you have a lot of footprint and schematic and then you combine it into one library. So in today's video we are going to learn on how to create your own component schematic and also the component footprint, so that you can use your own footprint or design your own footprint and use it in your kind of way. So it is very simple, but in order to create any component footprint or component schematic, all you have to do is to find the exact data of such a component. For example, we are going to create a 555 timer IC integrated circuit. So you have to Google or find the data related to this IC so that you can understand whether how big is the IC, what is the distance between the pin from one to one. So we are not going to download any data today, but if you do, you have to add a specific data. So what we do today is just a basic tutorial to show you on how to make it inside your Altium Designer 17.0 like I do. So if you have your Altium Designer 17.0, so go ahead and launch it, and once you have it right there, go ahead and get into File, going to create a new project, and then choose PCB project, choose the default one, and then click OK. Now we have our own PCB project. So all we have to do is to right click on the PCB project tool in here, and we're gonna select on PCB library. Okay, now you have two choices, is to first create a PCB library or first to create your schematic library. So now I decide to first creating the PCB library, so we don't have to go back again to create a PCB library when we have finished the schematic. So all we have to do now, when we launch the project, it will show something like that. Now let's go and bring some let's put some pin. For example, I'm going to design a 555 timer that is supposed to have 8 pin, which is 4 at the side, 4 at the side. Okay, I think I'm doing so ugly right now, but it's okay because this is just a demo. Right there, right there, right there, and right there. So probably a little bit messed up. So why do I suggest you to have your exact data or exact document about the pin that you are, about the IC that you are going to create? Is just because that if you don't have enough data, this is the problem. The distance between each pin is the problem. The distance between each side of the pin is the problem. You have to have a precise pin distance, so when you print out your circuit board, it gonna be look perfect to your IC, which means that you can go and soldering everything completely perfectly beautiful. Or if you don't have a data sheet and you just gonna do it randomly, I'm sure that it's not gonna fit. Probably your design is bigger, or probably your design is even smaller. So this is the issue. But we are not going to design very detailed about it. We're not going to download any data sheet. We just only show you on how to create and how to combine it together and how you can use your own designed footprint. So now once we have put on our pin, so let's say, imagine this is the right pin we want, and all we have to do now is to draw the appearance of our IC. So let's grab this, choose top overlay. Remember to choose top overlay for drawing an appearance of your IC. For example, I'm drawing something like this. Why are we suggest to use top overlay? Well, because when you design it when you finish your design and you want to print on the circuit board, this top overlay won't print out, or it will print out but on the top of your board, which means that it's not going to mess up with your PCB diagram or even the connection of your component at the bottom of your PCB board. So for example, that this is our PCB footprint. That for example, imagine that this is the exact pin of the exact appearance of your IC with the exact pin distance and everything working correctly. Just imagine that this was the one. So now go ahead and save it, and you have to save it to any specific location. Probably I said save it as test 1, or maybe I could go it for 555, and then we click on save. So now we have saved our 555 timer. Okay, so also to be noticed that this is the pin that you have designed having the right number on it, because you might have to know which number is going to what capability. For example, pin number 1 is the VCC, the power. Pin number 8 is a GND, it's a ground or something like that. So that's why an exact data sheet from the factory or related to IC that your design is relevant. So now once you have complete done that, just go back to your PCB. Now again, go to PCB project 2 that you have created and right click on it again, go into new project and create schematic library. So now let's design our schematic component schematic. So we're going to draw a box like this to represent our IC, and then what's next is the pin. So here is the important thing about pin that relate to our footprint, is that the number on the pin of your footprint have to match exactly the number on your pin that design on the schematic component. So now let's add the pin. You can just right click on it and click on place and then pin. So pin number 1 is actually VCC, as we have shown inside the 555 footprint like this. So this one is the VCC, which means as pin number 1, and this one, the 8, is the GND. And this is the other pin that have its own function. So now we only focus on pin number 1 and pin number 8 first, which means number 1 is the voltage in, the pin number 8 is the voltage out or ground. So go ahead back into our schematic. Now we have to add this. Remember that display name is what you are going to give it a name. For example, its function is a voltage in or VCC, so you have to fill it with VCC like that. And then designator is actually what you have to be careful, because this designator will have to be matched with the pin number on your footprint. For example, VCC on the footprint is not pin number 1, so the designator have to be assigned to pin number 1 as well. So now we click OK. So this is going to also to be noticed that VCC right here have to be get inside the box like that. So we have to turn it all around and put it inside, because it connect within the component. And then we're gonna add another pin like that. Anyway, if you're finding hard time to turn your pin around, just remember to turn it around. All you have to do is to press space like that, like that. Okay, pin number 2, pin number 3, pin number 4, and then turn it all the way around to pin number 5, 6, 7, and 8. Okay, so now we have to adjust the appearance of the PCB. Okay, like that. And then we rename this. So the designator is pin number 8, so it'll remain the same, but the display name we have to change so that we won't confuse. Change it into GND. So display name is not necessary, you can name whatever you want, but the designator have to be exactly the same as what it shown on the pin of your footprint. So press OK. So if you're happy with it, if you think that this is look great, now all you have to do is to go back into your schematic library. So you can't see anything right here, but it actually located down there. It said SCH library. Press on it. Now double click on the component at the left side, and right here the model you have to press add. Click on footprint, and then click on browse and find the one that match. So this is what we have just recently designed. So if you can't find what you have just recently designed, just go ahead and press it down there and find which one or the name of what you have designed recently. So this one is what we have designed, this footprint recently. Click OK, OK, and then we give it a name or whatever you want, default common. So this is optional for you. If you want to give it a name, just give it, or if you don't want, just leave it down there, and then we're gonna press OK. All we have to do now is to press save. So I'm gonna name it the same as what it just name it, and then I'm going to click on save. Okay, so now this is our schematic design, component schematic, and this is our component footprint. So we have merged this together, and now let's go ahead and try to place what we have just designed. So you have just designed your both component schematic and component footprint. All you have to do is to add your component into your library. So right here I don't have any component that I have created recently, but I have to add it. So go ahead and click on library, go ahead and click on install, choose install from file, and then you have to go into the project where you have saved your component schematic and footprint. I'm kind of confused on where I save it. Maybe it's inside. Not so sure, but let's see. Where is it? Home automation. Okay, probably in this home automation testing. Altium PCB2. Is that a PCB2? Okay, we have a little bit hard. So guys, we will come back after we find out where we actually saved, because I just confused on where I actually saved the file. Okay guys, so now we finally found the location where we saved. We have recently saved the file. So go ahead and click on library, click on install, choose install from file, and then we paste the location. Sorry guys, so let's choose the PCB and also schematic both, and then click on open. So now you have to install. So go ahead and click on the button search box down there, and you can see the word test, and you can pull it out. Okay, so I have locked this one, but we will click on create and add new project and go to schematic, and then we can go back to our test, and now we pull it in, and oh, it has freeze. So now, so here is the component that we have just designed. So all we have to do in order to see whether it works or not for PCB footprint, we go ahead and create another PCB file like that, and now we're gonna save this one as sheet 1, and we're going to save this one as sheet 1 as well. So the PCB and the schematic have to have the same name so that it could update the footprint into one file. So go ahead and then save it, and then now we have this file, and let's go ahead and put it on PCB. So we're going to design and update to PCB, validate chain, execute chain, and then close. So here you go, your own PCB footprint finally made it. You are now having your own design of your own PCB footprint. So this is all I have today. So this is actually on how you create your own component schematic and also your component footprint on Altium Designer 17.0. So if you enjoyed this video, please give me a like, or if you have any idea about this tutorial, just leave me a comment, and also don't forget to subscribe in order to get another new and interesting video in the next video. Okay, thank you guys, and see you next time, and bye for now.